All right, today's lesson is going to be a continuation of triangles, but we're going to look at how to find a missing side whenever we are given two similar triangles. All right, similar means same shape, but most likely different sizes. When thinking about size of our triangles, we're thinking about the different sides. So let's make sure you know how to interpret these similarity statements when looking at sides. All right, so similar means they would be proportional to each other. Sides are named by two endpoints. So in my first triangle, whenever I look at the first two endpoints, I can see that UV would end up similar to UL. The reason that I know those are similar to each other is because they are in the same position in the similarity statement. All right, so now my second set of sides I could look at, I'm going to look at the middle and the last endpoints given. So now I know that VW would be similar or in proportion to LK. And then our third set is found by looking at the first and end within each one. So now I know that side UW has to be similar to UK. All right, so that's what we're going to use to solve most of these problems. Let's look at the first one. All right, using that similarity statement, I'm going to make sure that I get everything set up correctly. First thing we want to use is a proportional chart for these triangles. And the way we set these up is a T-chart, and I'm going to name my rows and my column. I usually make my columns my triangle. So I label these to make sure I understand what I'm doing. I'm going to do top triangle in that column and bottom triangle in this column. Now I'm going to find the sides that I need to use. So if I look at the top one, I see that I've got side LK. So I'm going to mark it here off to the side. Now I need to figure out what side matches up with LK in the bottom triangle. So I'm going to go to my similarity statement. Here's LK. So that's first and last, or sorry, middle and last. So I need middle and last here. So that would be VW. All right, now I'm going to look at the other side given in that top triangle. I've got LU. So I'm going to put LU here. Now I'm going to look at my similarity statement. LU, okay, that's the first two endpoints. So that would have to match up with UV. So UV goes here. All right, so now let's go ahead and plug in those numbers. I look at LK, because that's going to go into that box. LK is 65. This box needs to be VW. Let's find VW. VW is here. That should be 117. All right, now I find LU. LU is right here. That would be a 50. And now UV. UV is right here. That's my unknown. So I'm going to use an X to represent my unknown. Now, a little bit of review from 7th grade. To solve a proportion is what you have here. We need to find the cross products. That means we're going to multiply on the diagonals here. So I'm going to do 65 times X. Well, that's just 65X. Then I need to do 117 times 50. Well, that is 5,850. And since this is a proportion, I know those are equal to each other. So now to solve for X, all I have to do is divide by 65. And I find out that X is equal to 90. So that means the measurement of side UV would have to be 90. All right, let's look at this one. This one we don't have a similarity statement because they're one on top of each other. So the way I'm going to set this one up is I'm going to label them as small triangle and large triangle. Now I see that I've got some sides marked, and I'm going to look at them and they look like a diagonal. I'm looking at those sides right in there. So I'm going to mark the diagonal here, and then whenever I look at what's given to me on the bottom, I'm going to refer to that as the base. Remember, these notes are just so that I can make sure I put them in the right spot in my T-chart. Okay, so this square right here needs to be the diagonal of the small triangle. Well, the diagonal of the small triangle is unknown. So I'm going to change that to an X. I'm going to change to some red here. All right, now in this box right here, I need the diagonal of the large triangle. Well, that one I do know, it's 143. Now, right here, looking at that box, should be the base of the small triangle. Well, that's marked as a 30. And now I need, in the last box, the base of the large triangle, which they're showing me right here with 66. So again, I find my cross products to solve this problem. X times 66, which is 66x. And then I need to do 30 times the 143, which is 4,290. And then finally, we divide by the 66 to find out that x is equal to 65. All right, and then in this figure, we will want to use our similarity statement. So I'm going to mark this as I see left and right triangles. So I'm going to go left and right and abbreviate. Now in my left triangle, I see that it's giving me side WQ. And let's find out what that matches. So I need to find WQ. It's in this statement here, and it's the endpoints, the first and last. So I go first and last here. That should be QS. All right, now the other side they give me here is the unknown. That's VQ is how I would name it. So VQ is first and middle. So I need first and middle here, which is QR. And this one was VQ. Okay. All right, now I'm going to plug in those numbers. So WQ goes into this box. So WQ is the 54. This box is QS. So QS is here. That's 63. Now I need VQ. VQ is here. That is the unknown. And now QR. QR, there it is. That's the 98. So now I do my cross products, and 63 times x, I'm going to move over here, is 63x, and that has to be equal to 54 times 98 is 5,292. Now I divide by 63 on both sides, and I see that x is equal to 84.